And we are live. Hey everyone, welcome to the Embedded Systems podcast. And as per the feedback from last time, what we are going to do is we are going to start off with an introduction. So, my name is Piyush. I work at Google on the tensor processor, write low level drivers. Um, I am an EE graduate from 2013 and been around 8 years in the industry. Yeah, so welcome to the podcast. Who wants to go next?
Yeah, I
Good
can go
job.
next. Uh, hey guys, my name is 𝗧𝗯𝗹𝗲, and I have been in industry for 5 years. For you know, you know, fresh out of college, I joined Samsung and worked there for a year, and then I switched to Google, and here, yeah, I have been here for around 4 years, working in uh, you know, team making Pixel devices.
Hello everyone, this is Wasim. So I have total 9 years of experience in domain. So I am 2014 grad and I did my BTech from Electronics and Communication. So I started my career as a tester. Currently I'm working in a Google and I develop software for embedded Pixel phones.
Yeah, that's an inspiring, would be an inspiring, you know
Backstory.
being
Yeah,
in a small company and then joining Google, right? So
yeah.
Thank you.
inspiring story, man.
Yeah, right. Yeah. So I've been in the industry for around 8 years. I worked in plenty of roles, starting all the way from design to applications. I worked on all portions of those stacks. So right now, I'm working in Google on the tensor chip.
Perfect. So I think hopefully that intro is, maybe we can reply back in the comments section if people need more information as to our backgrounds and our experience. Uh, well, now coming to the topic for today. So today we are going to discuss uh, having a career, or what a career in embedded systems looks like, what is like the scope of it, what industries, what domains, and what kind of job roles are available. And yeah, so maybe let me go ahead and share my screen so that we can have like a guided discussion. So first off, let me find it out. Yep. Okay, just let me know if the screen is visible to all.
Yeah.
Is it?
Yes.
Perfect. Okay, so the first thing that we do is maybe let's talk about, all the opportunities with respect to the kind of sectors and the industries and the companies that we have out there. Rajat, do you want to
Yeah.
walk us through this?
Yeah. So I think it's one of the biggest misconceptions in the world of embedded where people often ask me there are countable 8 companies on the finger where I can work. Like embedded is a very small
Right.
domain and there are only small companies, while software there are so many companies. It gives me an option, so why go for embedded?
Mm-hmm.
Well, actually there are only 8 or handful of companies that people know by name because they keep covering in the news because they are the front runners and they are mostly the OEMs and the semiconductor companies that get noted out. But there are several players that come into role. The semiconductor stack is a very big. It contains so many steps before you get a silicon or an end equipment out, and there are so many players that play a role in it. There are semiconductor service providers like Synopsys, Cadence, TSMC, Wipro, KPIT, Samsung that provide their integrated IPs to the semiconductor companies to put there. For example, Samsung is quite known for their DDI controllers. Synopsys is known for their multiple IPs and EDA tools. TSMC is definitely a manufacturer, but they also supply flash technology for their manufacturing technology as well. Then there comes the semiconductor companies.
So Rajat,
Yes.
Rajat, just a moment, Rajat. Could you speak to the keywords IP and what TSMC
Yeah.
does, and then EDA tools?
So IPs are like small portions of a complete chip. IP, the name actually means
Mm-hmm.
intellectual property, and it's a very abused name in the industry. You just put everything you have as a name IP. but here the IP means a small component in the chip. So sometimes when so there are several protocols which are like very specialized, and some companies masters in that. And it doesn't make sense for each company to develop that. So what they do is they license those IPs or intellectual properties from other vendors. For example, let's say I don't want to implement my DDI controller, or I don't want to implement some other IP. I can go to different vendors like Synopsys, Cadence, Samsung, etc., and license it from them and use it. So it's quite a common model in the industry where you take the differentiating factors and develop them yourself, and you license the common factors from other vendors.
Right. Okay. Fair. Could you speak to the keyword TSMC and which was the other one? EDA tools.
So
yeah.
EDA tools are the electronic design automation tools. You can think of them like the compilers for the design for transforming your RTL design into your actual chips. So EDA companies develop multiple tools that are used by the companies to come up with silicon. So there are multiple EDA vendors like Synopsys, Cadence, the tools like VCS, then Mentor Graphics have virtualizer, and there are multiple tools which are commonly used by these semiconductor companies to finally come up to their design.
Right. Cool. I think that should bring our audience to speed with the keywords. So okay, going back to the companies that you were talking about.
Okay. I think the second category that lies on is the semiconductor companies. And these are the companies which are quite popular because their name keep coming in the news quite often. We are all familiar with Intel, Qualcomm, and Nvidia. They are the giants of the personal computing industry. And then there are less known companies like NXP, TI, which make very specialized chips that go into day-to-day electronics. For example, TI is quite known for their DSPs in the past, and most of the phones used to have TI DSPs in it. Then NXP.
Okay, and for a
then NXP is known for NXP used to had acquired a company called Freescale in the past, which was quite known to be the centerpiece of a lot of ECU designs in the past. The ECU being the engine control unit of the automobile industry.
Right. So could you also maybe expand out DSP for the audience?
DSP, you can think of it as a CPU which is very specialized into doing certain things. So it's a compute that can do, let's say, matrix multiplication very fast. It has been specifically designed for it. And when you go into the industry of communication, DSP becomes very crucial because what happens is there's a lot of signal processing that you are doing on the fly. And you need a specialized, if you start doing that on the CPU is very inefficient at doing that. And it will spend a lot of time. So people came up with DSP specifically to fasten up those roles. And so coming back to the semiconductor industry, I guess these are the quite known semiconductor industry. And then there has been recent interest from quite big software companies moving into the semiconductor space. We also, it started with Apple in 2006 when they started manufacturing their A-series processors. And more recently, more software companies like Microsoft, Google, and Amazon has started doing their own semiconductors. With Amazon with their Graviton processors, Google with its Tensor, and I'm sure Microsoft one day or another will come up with its own. Maybe they have its own and it's not public.
Right. And then there is also
There is also Meta doing Oculus.
Yeah.
And the third category, and this is the fascinating one, where people don't realize there is a lot of embedded jobs. They just assume it's all related to a field because that's where the equipment gets used, are the OEMs. So if you have Dell, people assume Dell is just like assembling the components coming from someone else and just transfer and ship it out. But that's not true. There's a lot of embedded work that Dell does. The same comes from BMW. Audi, the automotive build companies, and you know what, you assume that it's all mechanical, people will be mechanical over there, but the backbone of the communication between these automobiles nowadays is so complex, and there's a lot of embedded jobs out there. Like a
Right.
high-end BMW can have as many as 56 microcontrollers sitting on it. That means 56
Right.
different
Right.
firmwares. So
Right. And from the
yes,
infotainment unit to the unit that controls the windshield and the windows, the wipers, tire pressure, like engine firing and fuel injection, headlights,
yeah.
whatnot, right?
And
All of this.
once you
Go
start
ahead.
with
Go ahead.
working in these companies, you realize that maybe Viper is a very complex component. It's not as simple as people think it is. There's a lot of firmware that goes behind it.
Right.
And
Right.
then there's the complete networking sector, right? The one that keeps the internet running, your data centers, your servers, your Wi-Fi routers.
Right.
So companies like Cisco,
Right.
Arista, Juniper Networks, they are again original equipment manufacturers. And nowadays there's payment industry as well. Pine Labs, PhonePe, Paytm, etc., doing their own embedded devices, on their own POS point of sale machines and MPOS, which is mobile point of sale machines.
Right.
So the
Right.
opportunity is huge. It's just that people don't realize it because these are
Right.
the
Right.
opportunities are very scattered.
Hmm. And they're not as much
Yes.
talked about actually. You don't see a lot of chatter about
Yeah.
it on the internet, specifically on YouTube and Instagram and Facebook and all of that. um, yeah, the chatter relating to these are like very less, but the jobs available in these sectors and companies, that is just like a
Yep.
huge number. Yeah.
We can also think about the defense sector. So complete defense sector
Hmm.
is all about embedded system, missile guiding system, object detection through radar, and
Hmm.
many
True.
things.
Yeah, I think I agree with that. Then we didn't even talk about aerospace here. So where would
So
aerospace
they
fit
all
in this?
also everything gets categorized into OEMs, right? The original eco.
I see.
So
Okay.
anything
Right. Right.
B2C,
Right.
business to customer, goes under OEMs, the original equipment manufacturers. So
Mhm.
aerospace, you can think of like
Right.
uh, whenever a ship gets there are multiple equipments coming from different vendors, and then there is again integration
Hmm.
task happening. And the same goes
Hmm.
actually goes for automobile sector as well, where even though the vehicle is BMW, not everything comes from BMW. They are tier 3, tier 2,
Hmm.
and tier 1 companies. Like
Right.
Bosch is a good example
Right.
of tier 1. Aptiv is a good example of tier 1. Mando being a good example of tier 1, where Mando specializes in braking systems, etc. And a lot of the braking
Right.
system original equipment comes from Mando and gets integrated into Volkswagen, etc. So it's tiers
Right.
of
Right.
OEMs.
Hmm.
So one of the interesting question here is that why these big names, the software companies, right? FAANG and many more companies, why they are moving into developing their own hardware, right? And any of us could answer that.
Right. So maybe let me take that first, and Rajat can extend that. So consider the case of Amazon, for example, right? So they have like a huge AWS cloud business, and in cloud business, what you're doing is you're taking like a server chip. First off, server chip itself, the design parameters for that qualify as an embedded thing. But then the server chip needs to run many operating systems on top of it, right? The whole point of you using virtualized CPUs. So then the question is, you have an operating system like Linux running many of those on the same CPU, and the layer of software that switches between the different OSs on that one CPU, the hypervisor, so to speak, um, that is like an embedded systems layer, right? Embedded code, so to speak. So these companies in such kind of roles would require embedded, folks. And also, you cannot achieve uh, providing such cloud services without dwelling into the hardware, without going in the direction of embedded. And this was like just one example. Then you have devices like, the Google Nest or Amazon Alexa, for example. Yeah, those devices again, require some compute power. And as soon as you have that, you need embedded engineers. Then the Amazon's Fire Stick, that also requires embedded components. Facebook's not Facebook, Meta's Oculus VR headset, that requires semiconductor and CPUs. So yeah, all of that. Rajat, do you want to maybe
So
extend?
I would like to, segregate this question into two parts. One is why FAANG companies need
Mm-hmm.
embedded engineers and why FAANG companies are moving towards, manufacturing their own chips. And I don't want to touch the
Mm-hmm.
second part in this because that's a whole topic of its own,
Right.
and we need to go
Yeah.
into depths of a lot. But embed, so wherever you want to differentiate yourself, wherever you want to have your devices, you need a embedded engineer over there, right? So if you want to make anything personal electronics, you need an embedded engineer. And on this, I actually want to, so there's a so one of the things I really find lagging about our education is that most of our definitions of embedded comes from 20-year-old books, where people say that
Mm-hmm.
running software on a general computing processor is not embedded. And I tend
Right.
to disagree with that. Wherever there's a software interacting with the hardware, it's embedded. Be it Android interacting with the
Right.
processor, be it Linux interacting with the processor, or be it, my
Right.
trimmer switching on the button and rotating my blades, that's embedded. So anything where software interacts with
Right.
hardware is embedded. And I was amazed, like a couple of days back, I was looking into NPTEL lectures and they were explaining that embedded software is not general computing. And I tend to usually
Yeah.
disagree with that.
Mm-hmm.
So a lot of these companies, if you look at their methodology, they do embed devices to to extend their reach. For example, let's say
Right.
take the example of Amazon. Like I feel the idea of doing Alexa is that a vision where people might be in future start ordering things with their voice. Start saying, Alexa, can you
True. True.
order from Amazon 1
Order
kg of
XYZ.
apples, etc. And somehow Amazon gets that order, and by the evening, Amazon delivers it. And there are multiple use cases like this
Right.
for the voice assistants. And one of the
Right.
things,
And
and
this,
also one of the things
go
is
ahead.
Amazon Go Mart, right? Which are opened in US, where you take the cart, move around the shopping mart, buy things, and at the end you just take out the card and it just tells you how many things have you bought. So how is that getting processed?
Right.
It's a sensor, it's a microcontroller doing all this processing on the back.
Yep. Some sort of a
Yeah.
QR code. Yeah. Yeah.
So
Definitely.
anywhere,
Yes. By the way, that also
yes.
reminded me.
So
Mhm.
anywhere, so
Well,
I'll just close it
sorry to
up.
jump.
So anywhere you
Good.
want,
Good.
so anywhere you want to interact with real world, that's embedded comes in. You want to interact software with
Yeah.
real world, you use a keyboard, embed. You use a screen, embed.
Well, key. Right. Right. And all of these,
Yeah.
again, do have a lot of firmware code within them, right? So, for example, the screens have screen color management code. The keyboards have the key press detection, and converting it to USB and sending it over to the machine, that kind of code. By the way, let me just go back a little bit. And when you were talking about the Amazon stores, right? So it reminded me that Amazon actually bought out free RTOS, right? And then Microsoft, I think, has
Yes.
ThreadX, and I'm not sure what Google has. I think they have, well, they have many, but I think Fuchsia is one of them. So yeah, that's that.
Yeah.
But yeah, go ahead,
So
Rajat.
I guess the buying of all these RTOS companies was majorly, so this whole concept of IoT, been there for last 10 years, just still waiting when that IoT boom will come. So everybody wants to prepare for that. And so the major thing about IoT is that everything should be connected. How do you connect them? Ultimately, everything
Right.
gets synced to cloud. And if you want, what are the cloud companies? Amazon, Google, and Microsoft. Google is still small compared to Amazon and Microsoft. But if you want devices to connect to your cloud, you need a specialized framework that can differentiate you from Amazon or you from Microsoft running on the end devices. And that's where I see Microsoft decided to
Right.
buy ThreadX, Amazon decided to buy FreeRTOS to capture those IoT devices so that they can develop specialized solution for the IoT end devices and control the end device stack.
Fair. Yeah. Cool. I think then with this, we can maybe move on to the domains and industries where embedded system is relevant. But we kind of touched upon this, but let's just formally call it out.
So, do you want to take it, Piyush?
Go ahead.
Yeah.
Yeah, sure. I mean, it's just that, embedded system, the field is so much omnipotent. It's just omnipresent, not omnipotent, but omnipresent. So medical devices have that. Obviously, the Fitbits and the fitness devices have a lot of embedded systems. Biological parameters, bioelectrical measurements, that's all medical devices. Well, visit to a hospital and some sort of scans, yeah, all those machines have embedded system in them, right? But definitely, and obviously, personal computing systems, the Wi-Fi, the docking station, your sound card, your Bluetooth, all of that is embedded system. Automotive, as we hinted, the braking system is embedded systems based. Engine management is embedded systems based. Steering wheel is embedded systems based. Seat belts are also embedded system based. Deployment of the airbag in case of crisis and safety system, that is embedded systems based. The elevators in the apartments, those are embedded systems based. The list just goes on, and industrial embedded system is like a thing in itself. So for example, the CNC machines are embedded system based. A lot of anything, I suppose, that has a sensor definitely is embedded system space, right? Then it's used like very heavily in avionics. The automatic pilot systems are embedded systems based. The sensors and actuators are embedded systems based. And of course, networking, which is again going back to the Wi-Fi, the telephone tower, all of the electronics there, that involves embedded coding and firmware deployment. So yeah, those are like the domains and industries, all of which have like heavy influence of embedded systems. In fact, they are like very heavily driven by it. Yeah. Do you guys want to add any more? Also, by the way, I must mention I have a brain freeze moment right now.
Yeah.
So
So I can
that's
I
that.
can take up
Go ahead.
industrial a bit more. So
Sure, go ahead.
a lot of things get hidden when we say industrial. Um, I'm not sure if you guys have been to a automobile factory or not. I have been, and if you look at the
Go
how
ahead.
cars are manufactured, you will see there's very less human interaction from starting to end. It's all robotic arms coming in, putting equipments,
Right,
connecting it,
right, right.
and a lot of embedded. Actually, a hell lot of embedded goes into it. There's just like thousands of processes working right over there to get that assembly line working. And without all those automation, getting cars at the pace we consume them out is simply not feasible. If we
Right,
start
right,
from humans, if we rely on humans to assemble a complete car, you may maximum get 4 or 5 cars in a day out.
right.
So
Well, I suppose that was Tesla's biggest problem in 2016, 2017,
yeah.
right? The production hell.
So similarly, automotive is a very big field, and there are simply a lot of companies. It's just not only the end companies like Maruti, Hyundai, etc. There's a lot of
Mm-hmm.
tier ones, tier twos, and tier threes that work towards to get equipment in the car.
Right. Anybody else wants to add?
So I would say
Maybe
that
I will.
on
Good.
a jobs number perspective, I know a lot of people believe semiconductor is the biggest paid influencer. So just to give you a number, like in Microchip, there were like 4 people working on motor control, might be,
Mm-hmm.
and our customer used to have
Okay.
like a 300-member team working on motor control, which are industrial and automotive customers. So there is a huge factor of difference between what these OEMs hire versus what semiconductor companies hire. And their
Mm-hmm.
OEMs are often
So
overlooked
you
in terms of hiring. People simply assume that the only companies that hire for embedded engineers are semiconductor companies like Intel,
the
NXP, etc.
semiconductor. Right.
But it's actually OEMs that make the biggest portion of the embedded engineers.
Right. 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 Perfect. Anybody else wants to extend this? Again, I'm not sure why, but I'm having a brain
Okay.
freeze moment.
So I want to
Go,
add
go
on
ahead.
industrial devices. So
Okay.
I got an opportunity to visit the rice mill, and I
Mm-hmm.
have seen the use of embedded system in each and every steps of rice processing. So there was a shorting devices which used to short the broken rice with the full rice, means complete rice,
Mm-hmm.
and it
Mm-hmm.
was complete embedded device, and there was a camera and sensor running to detect the broken rice,
Mm-hmm.
and there was color shorting of the rice also. So it was
Mm-hmm.
also complete embedded device
Mm-hmm.
to segregate the white rice with the yellow rice.
Right.
And same I have seen every in the each and every stage of the processing of rice.
Interesting. Well, actually,
And
this
one
is
more
not.
thing, in the industry, I have seen like automated oiling machine is getting used. So earlier people has to oil the machines manually, but now the automated oiling machines sense the temperature and the condition, and it oils the system
Mm,
uh,
right.
at that time.
Right.
So it
Right.
reduced a
Right.
lot of human intervention,
Right.
especially when you are shorting rice or running heavy machines.
Right. Right. I think makes sense. So it's kind of doing a self maintenance, so to
Yeah,
speak.
it is a kind of self maintenance of the uh, heavy machines.
Okay. Cool. Fair. So does anybody else have any doubts or wants to extend on this
So
further?
again, putting up some
Okay.
numbers for
Cool.
automotive, like I know that
Okay. Go ahead.
especially with the emergence of the EV, the number of embedded devices that
Mm-hmm.
are going to be
Oh,
there
wow.
is just going to increase. Now you have extra controllers doing BMS, extra controllers doing digital dashboards, then 360
Mm-hmm.
degree cameras, ADAS, etc. So the number of devices
Mm-hmm.
for the upcoming automotive cars is just going to explode.
Well, I maybe let me just paint an imagination on that. So let's say we take the Tesla car and ask the question, what part of it is like pure software? I would say maybe, the UI and the operating system on the instrumentation cluster and the dashboard, and every other bit of software in that car is
Yeah.
embedded, all of it, right from the key fob down to the, all the AI and the camera and the image
Yes.
processing, all of it. Perfect. Okay, do we want to move on then move on to talking to the job roles? and what are the skills people can focus on? Sure, who wants to take that up?
Okay, so I want to start my career journey. So
Go ahead.
actually, I have already worked in multiple roles which is
Mm-hmm.
related to embedded system.
Mm-hmm.
So I started my career as a tester, and there the skills required was only Python and understanding about the product. Like there, I was testing the IoT cameras, especially the surveillance cameras.
And where was Python involved in that?
So Python was involved to give the input, giving the input to the camera to function like auto
I see.
focus, auto uh, image. Okay, I forgot.
Acquisition. Huh. Okay.
Yeah.
Fair.
So
So could I say this, that Python was used like an
Yes.
infrastructure or a glue language again to test the
yeah, it
cameras?
was used as
Test automation.
uh, I can say a automation layer or
Mm-hmm.
test automation framework.
Mm-hmm.
Okay, and we were having the application where we were interacting with.
Okay. Okay. Fair. And so maybe what other job roles have you seen around you when you were a
So
tester or
I have
even
seen
after that?
multiple job roles around me. So at the same time, my teammates were working on Fitbits and watches. So
Mm-hmm.
for the testing of those things, especially the watches, we are having a robotic arm which we used
Mm-hmm.
to control through the software which used to run on the server. So from the server, we can move the watches
Mm-hmm.
or tilt the watches
Mm-hmm.
to
To test them. Mm-hmm.
accurately find whether it is working properly or not.
Mm-hmm.
And also uh, 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 finding like, so the process was like every day we used to get different builds, and those builds used to be flashed in the device, and we had to test each and every features that used to work, that
Mm-hmm.
is supported by that time.
Right. Okay. And then, if I may ask, after you were you migrated from the testing role, which was the next role that you landed in?
Yeah, so after 2 years, I migrated to writing camera HAL
Okay. And
for
what's a HAL?
IoT, and it was a framework which will help the testers which is above me to test the camera thoroughly.
Okay. Okay. So,
So the camera was having different use cases for different customers. Like
mhm.
some customer wants 4K video and 1080p video. Some customers want
Okay.
320p video and 720p video. So we have to make sure that based upon the customer build and the sensor type, we have to optimize. We have to run our test cases. So so it was a framework which used to detect the camera type and its
Mm-hmm.
functionality, and it used to read the camera register and capabilities,
Mm-hmm.
and it was understood by the above framework that these are the things which is supported.
Right.
So after that, I moved to automotive domain. There, I was working in audio middleware, and it was like the middleware software is something which runs on top of firmware or Linux kernel, and it is a glue between application software and the HAL layer or firmware layer. So our software, like audio middleware, was interacting with the DSP as well as the display panel, and also the different input sources like AXM uh, and FM sensors. I think we
We
lost
lost him.
Piyush.
Just continue. It will be getting recorded on that.
Yeah, yeah. And then after for 1 year, I worked in Cisco, And in Cisco, I was a part of OTA update team. So over the air firmware update team, and it was completely software job. And it is also embedded because we were solving the embedded bugs there. But the firmware update we used to give through the over the air as a part of over the air update. And currently, I'm working with Google, and I write low level software drivers.
So then why don't you talk about, I think you can talk about kernel, etc., since you started your career as a kernel and device driver developer.
Right. So I think when I started in Samsung, I was working on display drivers. So there, I think I also did the same what Wasim started with. So we had a bunch of boards, and we wanted to test those boards with Python automation script. So I think I worked on a small and the pattern finding framework, and with the help of that we were able to come up with a end to end uh, automation tool, right? And there I think I saw people working on device drivers, working on kernel, and then working on applications layers as well. And yeah, and I think after that when I moved to Google, here the people are working on firmwares, writing custom firmware to uh, you know uh, accelerate AI workloads. And so I think in Google I have seen people working on firmware development, device driver development, kernel development, verification, validation, and all of these components that you have mentioned here. I have seen people working around me on these roles.
I see. Okay, maybe if I'm to add, based on my experience, so I started off my career as a firmware development intern, and I was working on the GNSS chip. This was like back in Intel, 2016 timeframe. And then after that, well, first off, so people around me, so we had the testing and validation team, the verification team, and then there were kernel developers who would write drivers in the kernel that would interact with our chip, the GNSS chip. Then after that, I moved over to writing host software for Bluetooth. And as part of the host software, I wrote some BIOS. I added the support for Bluetooth keyboard and mouse in the BIOS environment, which is the UEFI, or like pre-operating system environment on laptops. So even there, we had like the device driver kind of role. And host software development would mean that you have the software stack that runs on the operating system. So from within the operating system, it interacts with the operating system's drivers, and the drivers interact with the chip. Right. So the first level of user space code would be called the host software, and then after that, um, again, I was involved in some verification and validation related activities for the RF chip or RF side of things for the Bluetooth. And interestingly, that job involved using Python to control the instrumentation cluster. So using Python scripts, I would send some command over the Ethernet to the spectrum analyzer and frequency generator. And that was interesting. So those kind of roles are also available. And then after that, I moved to Google, and I've been working on writing the validation software for the tensor processor, which involves again writing lower level code and drivers to control the CPU and other things on the SoC. Yeah, that's about it. And did we miss any of the roles
It's
listed
I
here?
cover them up. So I
Oh, sure.
think
Go ahead.
except
Go right ahead.
for
Yeah.
the actual hardware design, that means designing the PCB, I have one way or another worked in all these roles across my career.
Okay.
So uh, I definitely started my career as an application engineer in Atmel, and I think this is one of the most
Mhm.
conflicted field where people don't realize what actually application engineers do. And so the job of the
Mhm.
application engineer, I would say it's to ensure that the OEMs or the end customers don't face any difficulty with your services. You have to make sure that they go to production nicely. Even in production, they get any issues, you should be able to debug them and help them enhance their quality in return. So as application
Right.
engineers, we used to work with a lot of customers who used to use Atmel chips. And we used to, whenever they used to have any questions, they will drop a ticket to us. We'll try to reproduce their behavior in our systems, try to debug it, and provide them software or hardware workarounds. And on the parallel, you, as an application engineer, you work on reference designs. You create a reference platform that customers can use to develop their applications. So, for example, you can make a reference design of sensor fusion. So Atmel comes up with the sensor fusion boards,
Mhm.
show how sensor fusion software can be developed and sensors can be calibrated on Atmel devices. And the customer takes that as a reference platform and incorporates it in its applications. So field application is more of like going, not actually sitting on Atmel side, but actually sitting on the customer side. It's the same role, but these engineers actually sit on the OEM
Right.
side instead of sitting at. And
Right.
then I moved into developing Harmony SDK for Microchip devices, and that included a lot of middleware development, firmware development, device driver development, and kernel development. So when I say kernel, I don't specifically mean Linux kernel. Kernel can mean anything. Yeah, kernel
It's
means
some sort of an
anything that
OS.
abstracts hardware
Mhm.
from the application. This can be FreeRTOS
Mhm.
kernel, ThreadX kernel,
Right.
etc. I didn't work majorly on them, but in a way or way,
Right.
I understand them and I have to touch them because that was part of the application engineer role. You need to work on end to end.
Right. Well.
And
Mhm.
then,
Well, I wanted to take a moment. Could you maybe detail out or expand what firmware development
oh
is?
yes.
Because we had like few
Uh,
comments on our videos asking what firmware
so
development is.
firmware development, firmware again means it's not entirely software. It's a mix of software and hardware. So a lot of not all
Okay.
devices run Linux or any high level operating system. Some have a very less amount of code that is meant to do something very specific. A good example of that is motor control. Uh, how
Mm-hmm.
let's say you are running your wipers, the motors are getting controlled. There is some firmware running on that side. Then, if you take
Mm-hmm.
some kind of factory automation, etc., there is firmware running on that side. So, firmware is like there's a very shim layer between firmware and kernel development. I usually say firmware development is equivalent to
Mm-hmm.
kernel development. It's just that your
Sure.
kernel is not the end application. Kernel needs a user space, while firmware
Mm.
within itself is a user space and that abstraction.
Right. So, would you say that a, a complete software that sits on the CPU, minimalistic kind
Yep.
of just targeted toward one
Yep.
application, that
Yep.
would be firmware? Yeah. Okay. Okay. Perfect. Cool. Okay. Continue, please, because you were also going to speak, I
Yeah.
suppose.
And
Which are the roles after
yeah, I
firmware?
guess
Yeah.
after that I worked my career into emulation, which is basically validation and verification, where we used
Mm-hmm.
to do pre-silicon validation and verification of the microchip devices. And
Mm-hmm.
then I'm continuing that role at Google, where we do the pre-silicon validation and verification of the of the tensor processors.
Mm-hmm.
So, and honestly, like, yes, so there are differences in each of the roles. So whenever you are working on firmware development or emulation or validation kind of scenarios, you might be limited to some portion of the SOC, the system on chip or the complete chip.
Mm-hmm.
You may not need to do at a system level, and this includes more of programming than debugging. But when you are in a role like application, you work on a system level, and at this point, more debugging skills are required than programming.
Mm-hmm.
And I guess the differentiating skill is definitely debugging. So so this is what differentiates software from hardware, right? Software engineers from embedded engineers. Software engineers usually don't worry about what's going in the hardware. They just assume that Intel processor is working correctly.
Right.
But when you are in embedded, you always
Right.
the first blame
Right.
you put is on hardware, not on your software.
Of course, yes. Because your software is always correct. Yeah.
Yeah.
Definitely. Like, I'll just extend this a little bit. What I've come to understand is that embedded, it's more about the system, right? So system's the king here. How different things are interacting and talking together, that matters a lot more than the software itself. The software matters, of course, but the software matters in the grand scheme of many things interacting together. And at least I have run into situations in the past where the code wouldn't execute correctly because the cache system was misbehaving, right? Because it wasn't holding up the charge correctly, and bits were flipping. So yeah, having a system level knowledge helps. That said, let's maybe come towards the closing topic for today, which is quickly maybe just hint at the skills that uh, would allow someone to kind of plan for or prepare for entry level jobs. So what are the skills you would recommend, skills or topics you would recommend that people should focus on, those seeking entry level jobs? So maybe I'll go first. So C definitely, and CPU definitely, and within this I would recommend that people do ARM-M, ARM, okay, where is that? Man, how do I write? Okay, A or RISC-V CPUs. Study any one of them. All of them are similar. One, all others. Little bit of assembly, right? And maybe the tool chain. So what, as per me, these will do, knowing, little bit of this. Obviously, no C in as much depth as possible, but knowing the rest along with C, it just helps you get onto a team and then contribute. They'll be able to guide you better. You'll understand their language better. You'll be able to interact and self-navigate better. What other skills would you guys
I
suggest?
I
think
have a bit of differentiating view on this. I think a lot of jobs in
Mm-hmm.
embedded doesn't need to know you anything about the processor you're working. So,
I see. Okay. So you're saying
if
this.
you're working on kernel development, it's
Mhm.
good that you don't know the CPU because that way you can write a better kernel.
Fair.
In
Fair.
places where you're writing middleware like TCP/IP, you don't need to know the CPU you are working on. You are more concerned about the Ethernet.
Definitely is.
So for
Definitely is.
entry, I think for a good starting point, uh, knowing less hardware may not be a problem. If you know less hardware,
Hmm.
it is not a problem. But
Right.
definitely, if you want to grow in career,
Hmm.
knowing more hardware will help you grow
Mhm.
in career in embedded.
Hmm. So maybe I'll just draw like a
Hmm.
graph, something like so
Yeah,
maybe. And then of course you don't have to know like all of
yeah,
hardware. After a certain point, you can just, well, everything's a register,
exactly.
read and write after a certain point.
Yeah,
So yeah,
Yeah.
finding which one
yeah.
becomes the tricky part.
Yes, Wasim, you can say
Cool.
sorry.
Okay.
I interrupted
Yeah. So I want to add, like, if somebody want to start their career with the testing and validation, then Python is the must.
Mm-hmm.
With Python, if they know shell scripting, then it is
Yes.
cherry on the cake.
Right. And maybe general familiarity with Linux environment also helps.
Yes.
as
especially the Linux command sudo
right.
access and frequently used Linux commands.
Yes. Okay. So I think, yeah, that sounds like a complete list to me, at least for somebody who's just, getting started. Any final
Yeah.
suggestions or,
I
comments
can
on this?
also write like if somebody is starting very early in the
Mm-hmm.
embedded system, uh, I want to reiterate the points. Like the person should know C very well, especially the pointer access.
Mm-hmm.
Okay. And apart from that, he should have a knowledge about uh, CPU or
Mm-hmm.
complete one processor architecture.
Right. But this is not like super important. Knowing
Yeah,
is like,
but it
Right.
is good to have like how
yes,
the CPU instructions goes inside and work. The
sure.
memory model and the what I can say that the memory, CPU, and peripherals, how these three things interacts
Mm-hmm.
with each other.
Okay. So these are like your top two recommendations.
Yeah,
And
for
then like
the
obviously apart from, if somebody's starting in test, then the above ones, but in general, these. Fair.
So I, I
uh,
think when I
this
started
point,
working on,
uh,
Good.
along with
yep,
the pointer, if you can add structures, then
Oh
right,
yeah,
yeah,
of course.
makes sense.
yeah.
Right. Good.
So yeah, I think this list is very comprehensive, and I feel intimidated by this list. But I think when I started, uh, embedded domain, I only knew C language in depth,
Mm-hmm.
and then of course pointers, structures, and all these things. Uh, Other than that, I think what I knew was how memory works,
Mm-hmm.
the memory model, right? How CPU fetches, the data
Instructions, yeah.
from
And
memory, and
mm-hmm.
yeah, and then and how it processes, like all those four stages of uh, you know processing, and a little bit of caches, right?
Mm.
How you have the data from DRAM fetched to the caches, and then CPU uses those data, right?
Fair, fair.
So, and this is very much available everywhere. Even you start with a simple tutorial, they would teach you these
Yeah.
things, and this is what I all knew.
Mm-hmm.
And after that, I think you keep on building, understanding these things,
Yeah.
learning along the way.
I would agree with
So
that. Yeah. Perfect.
yeah.
Cool. Okay, so I think maybe we can call it a podcast for today because I see that we might run over time for today. Um, so I want to reiterate this that I had posted on the community tab uh, requesting for topics that we can include in our podcast, and people responded with a lot of different topics. We tried to talk on few of those today, and what we'll do is in the next podcast we'll kind of select a few more and then talk in depth on those. So yeah, thanks for joining in for today, and maybe we can call it a podcast.
All right.
Okay, cool. So stopping the recording. Bye bye.